Howdy folks, this time let's build a molecular model starting with actual data. I'm using serotonin for this example, where this is the SDF file for serotonin, which I downloaded off of PubChem. The data in this red box gives us the X, Y, and Z coordinates for each of the atoms, with the fourth column telling us which element it is for each atom. This data in the red box down here tells us what the covalent bonds are. For example, the first bond on the list is a single bond from atom number 1, which is the oxygen atom, to atom number 12, which is the next to the last carbon atom on the list. And there's a double bond from atom number 4 to atom number 8, and so on. Modeling the atoms in Blender is just a matter of not screwing up anything when typing in the X, Y, and Z coordinates. Putting the bonds in the right place is a little bit harder, or at least it was for me, because I couldn't figure out any way to tell Blender to draw a cylinder that starts at this set of X, Y, and Z coordinates and ends up at this other set of X, Y, and Z coordinates. I do know how to tell Blender where the cylinder should start, how long it should be, and how to rotate it about the X-axis and the Y-axis. Now I just have to figure out how to calculate what the rotation about the X-axis and Y-axis should be, given the data in the SDF file. Here are the formulas. We have to calculate the rotation about the Y-axis first. If delta Z is greater than 0, we need the arctangent of the delta X over the delta Z for the two elements on either end of the bond. And if the delta Z between the two atoms is negative, then we have to add pi radians to the rotation about the y-axis. And if the delta Z is exactly equal to 0, well, then don't do that. Change one of the Z coordinates by a tiny amount so delta Z is not exactly 0. We can then calculate the angle of rotation about the x-axis. Just be sure not to forget the negative sign out in front. As in the previous video, we need to start the cylinder for the covalent bond on the z-axis. This is so we can use the delta transform thing to rotate around the bonds as we wish once the model is complete. We need to scale the cylinder in the z direction as half of the bond length. Then we need the x, y, and z coordinates for the first atom, and then we need the rotations about x and y in degrees to swing the bond around so that it ends up on the second atom. Someone who knows what they're doing can probably write something in Python to do all this math automatically, but I just do it with a spreadsheet. If you want to follow along as I build the spreadsheet, here it is. I started with the data from the SDF file, then I numbered the atoms sequentially, and filled in the name that I'll assign to each atom in Blender. I did the same thing for each of the bonds, but I moved the bond data over and down a little bit to give me some space and to get the names lined up. Now I need the X, Y, and Z coordinates for the from atom, the first atom on the bond. Bond 0.001 is going to start on oxygen 0.001, which is atom number 1, and then go to carbon 0.009, which is atom number 12. So the delta X is D12 minus D1, and so on for the delta Y and the delta Z. The bond length is the square root of the sum of the squares, just our old buddy Pythagoras. And there's the formula if you're using Excel, there in the red box. Because of the way Blender does the scaling factor, the first number I need for the gray cylinder is 1/2 of the bond length. So I put that over there in the F column. There's the formula for a rotation about y. If the delta z is less than 0, add pi. If not, don't. And there's the formula for rotation about x. By default, Excel calculates trigonometric formulas in radians, and Blender, by default, wants the angles in degrees. I could figure out how to change the defaults, but no. Over there in the J and K columns, I've just converted the radians to degrees. So these numbers here in the red box are the numbers I need to type into Blender to specify the location and rotations for each of the bonds. And they're in the order I need to type them in. Okay, so here are all the atoms for serotonin. And up here are my 26 bonds, which aren't doing anything yet. So now I need to move the bonds into the correct positions. But first, let's double check all the atoms. There's carbon number 1. You can see his coordinates: 2, 3, 4, 5, 6, 7, 8, 9, 10. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Nitrogen, oxygen, oxygen. Oh, 2 nitrogens, 1 oxygen. Okay, so there's all my atoms. I've double checked they're in the right place. I'm going to go to bond number 1. And remember, I need him to be on the z-axis, so x and y coordinates of 0. And then the z-coordinate is going to be 1/2 of the bond length. And that's also going to be the scale, 1/2 of the bond length. Then set the origin to the 3D cursor. Now I'm going to move it onto the oxygen atom. So everything's zeroed out except the scale and z. And now x, y, z. So now there's my bond 001, where the origin of the bond is at the center of that oxygen atom. And now I need my rotations. Rotate about x. Rotate about y. And so now there's the bond going from that oxygen to that carbon. And if I look at it from above, okay, still looks good. I think I didn't screw that up. Okay, now we need to do the same for the other 25 bonds. Now this one's a double bond. This one's going to be a little weird. So there's my cylinder with the origin at the 3D cursor. This is bond point 011. To make it a double bond, I'm going to move that first cylinder over a little, 0.075 in the negative direction. And then I'm going to duplicate, right-click, positive 0.075. So now there's the 2 cylinders for my double bond. Set origin to 3D cursor. Set origin to 3D cursor. So there's my new cylinder, which says it's bond 27. Click, shift-click on bond 11. Now I could do the object-parent-object trick, but I never want these 2 cylinders to be separate ever again. So instead of object-parent-object, I'm going to do object-join. And the difference is it's not children and parents, now it's just one object. Now the next bond is also a double bond, same trick. But now I can see he's a double bond when I look at it from that direction, but when I'm looking at it from above, it's not lined up with the plane of the ring. Well, I can do that delta transform thing that we were talking about in the last video. So rather than have the rotate about x and rotate about y in the transform, if I move them down to the delta transform, now I can rotate about the z-axis, and that pair of cylinders is rotating about the local z-axis. So rotate about x, rotate about y, and delta transform changes the local axis for my double bond, and now rotate about z in the regular transform, and I can make it fit my plane of the ring. Okay, more bonds. Another double bond. Another double bond. Okay, all my bonds are there. I want that hydroxyl group to rotate, and I want this carbon-carbon-nitrogen tail to be able to rotate about all those single bonds, with the rest of the ring just being stable, or stationary. So there's the bond for the hydroxyl group. I'm going to do the same thing. Instead of the rotate about X and Y in transform, I'm going to move them to delta transform. And I'm just going to copy paste. Copy. Paste. Now it looks weird until I delete those. Okay. Now I'm going to shift click for the hydrogen, the oxygen, that bond, object, parent, object. Now if I click on that bond, again the z-axis is now local to that bond and I can rotate about that bond. Okay, same thing over here for the amine group. Copy. Paste. Copy. Paste. Delete, delete. Or 0, 0. Click on the hydrogen. Click on the bond. I missed the bond. Okay, let me look at it. Oop, other side. Okay. Now the bond. Hydrogen. Bond. Bond. Object. Parent. Object. So now the amine group is rotating around that single bond. Undo. That guy. Copy. Paste. Copy. Paste. 0, 0. Hydrogen, bond. Carbon, hydrogen, bond, bond. Now the last bond I picked is the yellow one. That's going to be the parent. Object, parent, object. Rotate. Okay, but it's just rotating that methylene group. I'm going to parent that group to that bond. Now when I rotate that bond, it's taking the amine with it, but I can still rotate the amine separately. Undo, undo. Last rotatable bond. Copy. Paste. Copy. Paste. 0, 0. Click, 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 click. Object. Parent, object. Again, just that one. Undo. Going to parent that guy to that guy. Now he's taking that whole tail, but I can do those two, or I can just do the amine. Undo, undo, undo. Okay. Does that still work? Okay. Now that carbon right there is nearest to the origin of the 3D cursor. I'm going to make that the center of everything by gathering up all the other parts and parenting it to that carbon. Parenting them to that carbon. So I'll start down here. Click, shift click, shift click, shift click, shift click, shift click, shift click, click. I just needed that bond because remember that whole tail is a parent. Click, 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 click. Just the bond for the hydroxyl. Click, 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 click. And then the carbon. Object. Parent. Object. Again, the parent model is going to be the last thing you clicked before object, parent, object. I'm moving it to the origin. Now I want to rotate it so the plane of the ring structure is in the XZ plane. So, okay. And then I need to rotate about Z. Other way. No, too far. Click, click. One more, one more. About like that. Now when I look at it from the negative y-axis, hey look, I'm straight ahead at the plane. He can rotate, undo. He can rotate, undo. He can rotate, undo. Oh, he can rotate. Now I'm going to undo. Undo, undo. Save. Okay, let's do a quick animation like we did last time. Half a second of nothing, so 15 frames of nothing. Animate that variable only. 2 seconds. 75 total frames, 360 degrees. Animate that one. Make sure it works. Fabulous. Fifth, half a second would be 90. Yeah, that one. Animate. 60 frames, 150, 360 degrees. Animate. Another 15 would be 165. Next bond. Nope, the bond. There we go. Animate. 2 seconds, 60, 225. 360 degrees. Click. I need more. Okay. Half a second, 240. That guy, starting at 0. 2 seconds, 60 frames, 300. 360 degrees. Click. Another half second of nothing, 315. Click. Okay, so I don't need 500 frames, I need 315 frames. Go back to frame 1. Spacebar. Okay, render that, and I think we're done.